Hey, it's geometry time again. Happy geometry video to you guys. It should be like a Wednesday or something when you're taking a look at this, something like that. Anyway, I hope you're having a good day. Here we are back talking about dilations. Here's a warm-up for you. An optometrist dilates the pupils of a patient's eyes to get a better look at the back of the eyes. A pupil dilates from 4.5 millimeters to 8 millimeters. What is the scale factor of this dilation? And there's a little hint for you. I'm going to let you pause this and calculate that out. Off you go. All right. So here's how you solve this problem. Remember, our little hint is a little formula for calculating scale factor, and that's what we're trying to do, calculate the scale factor. And on top, CP prime indicates the distance between the center of dilation and the object after it has been dilated. So that's a hint. And then the bottom is the distance between the center of dilation and the preimage, or the object before it has been dilated. So notice that this problem says a pupil dilates from 4.5 millimeters to 8. So it starts at 4.5 and goes to 8. So CP prime, which is the measure of the the image, is what goes on top. So it goes from 4.5 to 8. And so the 8 goes on top, and the 4.5 goes on the bottom, which ain't pretty, but you can plug that into a calculator fairly simply. 8 divided by 4.5 is 1.777 blah, blah, blah. Let's round it to 1.8. And so the scale factor of that dilation is 1.8. That pupil has gone almost twice as big, but not quite. And there you go. That's how you calculate that. Keeping in mind that CP prime is the distance after the dilation, and CP is the distance before, you can calculate just about any scale factor. All right, it's notebook time. I don't even need to tell you what to do anymore, right? So I'm just going to let you pause the video, do it, and come on right back. Okie doke. Here is your new topic, an essential question. Your topic is dilations with negative scale factors. Your essential question, how do you dilate a figure with a, oh, it says positive. Oh, Miss Wait, not reading the slides. This should say negative scale factor. How do you dilate a figure with a negative scale factor is your essential question. Make sure that topic makes it into the table of contents of your notebook along with the page number. All right. So a quick rewind, just so we're all in the same place. Remember that what some of these things mean. A dilation is a transformation where objects change size. This should already be in your notebook, but if it's not, now's a good time to get it in there. A scale factor is the measurement of the dilation, the thing that determines how big or small the dilation is. There's a rule for dilations, and it looks like this. Take every point x and y and change it by the scale factor. Take each point, multiply it by the scale factor, you get a new point. An enlargement is where things get bigger, and this is where your scale factor is bigger than 1. And a reduction is where things get smaller, but that's when your scale factor is somewhere between 0 and 1. Not exactly 0, not exactly 1, but somewhere in the middle. So that's kind of what we talked about last time, you guys, last time I made a video for you. For me, it was about 5 minutes ago, just so you guys know. Anyway, so then we could use these ideas to make a new graph of a new triangle after it has been dilated. So for example, we're going to graph triangle ABC with vertices at A, B, and C. You can see that I've already done that. And its image after a dilation with a scale factor of 1/2. Remember, we have a rule. we can take each point and we can multiply each part of that, each x and y coordinate by the scale factor, and we will get a new point to graph. So A lives at -6, 6, and we want to find A prime. Well, we just have to run it through the rule. Now, what is -6 times 1/2? -6 times 1/2. We could do this a couple of ways. We could say -6/1 times 1/2, and then -6 times 1 is -6, and 1 times 2 is 2, and that gives us -3. Or we could just recognize that -6 times 1/2 is the same thing as 6 divided by 2. -6 divided by 2. So you can work with these fractions. That's why we did the fraction review at the beginning of the year. Or you can just ask yourself, well, how does this work? What is half of -6? Well, it's -3. What's half of +6? It's 3. And so now we have a new point that we can graph, A prime, which lives at -3, -1, 2, 3, +3, 1, 2, 3. And here is the location of A prime. We can do that with B also. Let's see, B lives at 6, 8. So B prime is going to be half of 6, which is 3, half of 8, which is 4, and now we have a location for B prime. +3, 1, 2, 3, +4, 1, 2, 3, 4, and here is the location of B prime. Last one, C is at 4, -6, and we want to transform it to C prime, so we're just going to divide those numbers in half. Half of 4 is 2, and half of -6 is -3, and so we have a new point at 2, -1, 2, 3. This is the location of C prime, and now we can connect these dots and see that what we've created is a triangle that is half the size of our original triangle. And that's how you do it. You take the points, you run them through the rule, you get new points, and then you plot them. So that was a review of the last video, just to kind of make sure that we're remembering from day to day. Today we're going to be dealing with negative scale factors, and they work exactly the same way as positive scale factors. You still use the rule, take every point and transform it by the scale factor. Multiply each number by the scale factor, except now something kind of interesting happens. So let's see what happens. The process is the same as we just did. So we've got triangle FGH with the vertices at F, G, and H, which is already plotted. You can see it. And now we have a scale factor of -1/2. Notice that scale factor is negative. And so we're going to see what that does to this object. So here's F. The problem's telling us that it starts at -4, -2, and we're going to find F prime by multiplying both the -4 and the -2 by the scale factor of -1/2. Well, let's see. A negative times a negative is a positive, and half of 4 is 2, and so our x value of that point is going to be 2. And then again, a negative times a negative is a positive, and half of 2 is 1, and so we have a new point at 2, 1. So here's 2, 1, and this is where F prime lives. All right, let's do another one. G starts at -2, 4. We want to find G prime by running it through the rule. Well, let's see, -1/2 times -2, a negative times a negative is positive, and half of 2 is 1, so that's a good start. And then -1/2 times +4, a negative times a positive is negative, and half of 4 is 2, and so we have a new point, 1, -2. 1, -2, and this is where G prime lives. One more. we have h, and it starts out at -2, -2, and we want to find h prime. Negative times a negative is positive, and half of 2 is 1, and then it's also going to be 1 because it's all the same. Half of 2 is 1, and a negative times a negative is positive, so there you go. And h prime lives at 1, 1. 1, 1 right here, h prime. So, now that's different than what we've seen before. Because when we've dilated before, and we dilated by positive 1/2, the triangle just shrank. And it stayed kind of the same orientation as the original triangle. It just got smaller by half. In this one, it completely changed locations, and this is exactly what a negative scale factor will do. It will actually flip the object 180 degrees around the origin, and it will also do the dilation that you expect. Because the dilation has a 1/2 in it, it's a number between 0 and 1, and therefore it got smaller. But what that half does is gives it a little flip. So that's why we can say when k is less than 0, in other words, when the scale factor is a negative, when k is less than 0, it is the same as a dilation of k and a rotation of 180 degrees around the origin. Well, that's a good thing to get in your notes. Go ahead and pause and do that, and then I'll reiterate again. So going back to this first example, a scale factor of positive 1/2, in other words, somewhere between 0 and 1, just shrinks the object. But if it's negative 1/2, it shrinks the object, but it also flips it 180 degrees. That's what the negative does. So when your scale factor k is less than 0, in other words, negative, it's the same as a dilation of k and a rotation of 180 around the origin. And that's the key to negative scale factors, folks. It comes with a rotation embedded in it. It's kind of cool. And that's what computer programmers do when they want something to flip around and shrink or flip around and grow. They just tack a negative into their scale factor calculations, and it does it automatically. It's magic. So let's find the coordinates of the image of a triangle with coordinates f, g, and h after a dilation of -2. Describe what it would look like on a graph. So we're not going to take the time to graph it, but we are going to describe what it will do. And so let's find those coordinates. Well, we remember that anytime we want to dilate something, we want to use the rule, and the rule is take every point x and y, and then multiply each x and y by that scale factor. So we're going to take f, which lives at 3, 6, and we're going to turn it into f prime by multiplying the 3 and the 6 by the scale factor of -2. So 3 times -2 is -6, and 6 times -2 is -12. So there is our first new coordinate point. And then g starts out at 3, -3. So it's going to go to g prime, which is 3 times -2, or -6, and then -3 times -2, which is +6. And then the last one, h, goes to starts at 6, 6, and it's going to go to h prime, which is going to be 6 times -2, or -12, a couple of times. So that's the first part. We found the coordinates of the image of a triangle with coordinates blah, blah, blah after a dilation. That's these points right here. Those are those points. Now, if we had a graph, we'd throw that on there and we'd be able to see it. But instead, we're going to describe what it would look like on a graph. Well, as we know from the previous slide, when the scale factor is less than 0, it's the same as a dilation of that scale factor plus a rotation of 180. And so a dilation of -2 would be, what would it look like in a graph? The object would get twice as big because of the 2, and it would flip 180 degrees because that's what the negative does. So the object will get twice as big because that's the 2 part of that scale factor, and then it would flip 180 degrees because that's what the negative does. All right. That's it. Not a whole lot to it. Your topic, dilations with negative scale factors, came with an essential question. How do you dilate a figure with a negative? Copy and paste. Better check it a little more carefully next time. A negative scale factor, that should be answerable at this point. If not, office hours are a thing. You can come and get some help. Your practice is going to be on big ideas math. It's called Dilations, and it should be open by the time you get this video. Anyway, I hope you have a wonderful day and that you find something fun to do with part of it. All right, you guys, have a wonderful one. Bye.